Hey everybody, Emily from The Joy of Coding here, and I am so excited to share with you today. I've heard this in a bunch of different places. I've heard questions about, gosh, do I need to know how to do math to be a six-figure developer? Do I need to be good at math to be a coder? And the answer to that is no. And I'm going to tell you why, and I'm going to share with you why there's a history of this, of why people have gotten this perspective that you absolutely have to be an amazing math whiz to become a coder, because it's absolutely not true. So let me share first the history of this a little bit. So why do people have this idea that we need to be amazing mathematicians to be coders? Well, it comes into the history of where computer science and programming was born. So when computers just first came out and you could program them, like in the 40s, 50s, 60s, 70s, there was no such thing as computer science. There was no such thing as a degree you could get or a boot camp you could go to learn how to program. So the people that built computers were like, okay, who can we find to teach and train how to code these things? And guess what? They found mathematicians. Now, there was a reason for that, right? There is types of thinking that can help, but it's not unique to math. That's the thing I want you to take away from today, is that it's not just mathematics that has these skills. There are many fields. There is English and physics and art and music and so many areas that teach these same skills. But it was just when computer science was founded, when the first programmers were being trained, they happened to be mathematicians. That happened to be where they went. Why? Because mathematicians are trained to think abstractly. Okay, so I'll repeat that again. Mathematicians are trained to think abstractly. But abstraction, so what does that mean? The ability to abstract. So for example, let me take an example. I don't have a car in front of me, a toy car. They're all downstairs. Sorry, I don't have a hand example. But imagine a toy car. It has four wheels. It might have a steering wheel. It probably has doors that move and you can push it and it goes. It is not a real car, right? Like, we totally know that the pretend car, the toy car that our kids play with, is not a real car, right? It doesn't have an engine. It can't actually drive on the road. It has no pedals. I can't get inside it. And yet we still know that and recognize that it's a car. So the toy car is what's called a model or abstraction for a real car. Okay? So the ability to think abstractly is the ability to kind of recognize things at a higher level. That's it. So math does this all the time because a mathematical formula or an equation, it's just representing some kind of phenomenon in the natural world, and it's condensing it into this higher level formula that describes the quantity, that describes the action, the activity, whatever it is. Okay, so mathematicians think abstractly, physicists totally think abstractly, right? Like, that's why calculus was created in the first place. It was for physicists to model the natural world so we could explain, when an apple falls, how far does it bounce? How fast does it go? And all those good things. So mathematicians and physicists, yeah, they do a lot of abstraction, but they're not the only disciplines. So for example, I know some amazing programmers who are musicians. Because guess what? Reading music, the musical notation, it's an abstraction. The music on the page has, what relationship does that have to the keys on a piano? Nothing, right? There's these little dots and lines. There's no dots and lines on a piano. So musicians think abstractly, right? If you can play music, if you can read music and play it on any instrument, you are thinking abstractly. You do not have to be a mathematician to be an awesome developer. Other fields that do this, art, right? We can draw a sketch of a happy face. I know I can probably, if I was faster, I could probably put one up for you on the screen right now, but imagine a smiley face with a circle and two dots for eyes. That's an abstraction of a human face. It's not a human face, but it represents it and we can recognize that. And in fact, some of the most amazing programmers on the planet who have been super impactful, not mathematically inclined at all. So you may or may not have heard of this, but David Hovenmeyer Hansen, DHH for short, because it's a mouthful, he is the creator of Ruby on Rails. And so basically, this is a web framework, it's called Rails, that uses a programming language called Ruby that we use on the internet. He created this thing called Rails, and it underpins like a ton of modern websites. It was huge. You know, it was really, really popular. If you've heard of like Django or React or Node.js, all of these things happened later. Like React was the cool kid on the block for a really, really long time. I think people are going in a different direction now, but Rails is super, super amazing. And guess what? DHH, he was an English major. He's really good at writing words, not necessarily mathematical formulas. And he created a web framework that's in use by websites all over the world. Yeah. So when I say you don't need to be a math whiz to be an awesome programmer, I'm not just talking out of thin air. Like there's actual evidence. Like there's a ton of people that have become, you know, amazing coders and done amazing things to transform the world who didn't have a lot of math skills. So that's the history. You don't have to be concerned if you are not necessarily mathematically inclined, that's okay. So we don't need all of math. And the other piece I can share with you about the history of computer science and why people think that they need math to be a coder, it's because many computer science degree programs historically require calculus. Now, I was a math minor. I did all the courses. My parents were math majors. Oh, thank you so much, Arthur. Yes, I was going to get to this today. Yes, if you're doing graphics, that is the one place you anticipated. I love it. The one part of computer science, the only one that uses calculus is graphics, because you're modeling physical systems. It's dealing with physics, right? So if you have an applied system where you're applying mathematical equations or modeling physical phenomenon, yes, it is super helpful to have that math background, okay? But that's it, right? Graphics. So only if you're, and when I say graphics, I don't mean just like creating figures and bar charts. I mean like you're literally working on the rendering engine for a gaming company or a movie company. You could still work at the movie company and be a coder and use that rendering system and not know the math, right? So it's literally only for the people that have this really special purpose of like, you know how like, have you seen digital movies where like they had computer graphics and they started off with like the hair used to be kind of like just wooden and now the hair looks really bouncy, or the fire looks really realistic, or the water is really rippling, like in the latest Frozen, like the water looks super cool. Like the person that makes that water look cool and react with the environment, that one person, there might be like 300 other people working on that movie or working on that video game, but there's one person like, or a handful, a very small team working on that rendering engine. They are the people that need the math. So if that doesn't sound like the type of code you'd like to create, like you don't have to worry about knowing the math. So thank you so much, Arthur. I was totally gonna get into that as well. I love how you anticipated it. And so the last thing I was gonna say on that topic was, historically, the reason we have this in our minds that every computer scientist or programmer needs calculus is because degree programs historically required calc, even though it's only used in graphics. Now, why? Why would they do such a thing? And in fact, I created a computer science program where we didn't require calculus. We just required statistics because we thought that was way more useful, but you don't actually need that either. Oh yes, and Arthur, I am so gonna explain how much math you might need to know down the line. Absolutely, that is on the list today. So hold that thought, I will get there in just a second, thank you. And so computer science programs historically required calculus. Okay, why? Because they wanted mathematical maturity. So even though a lot of areas, we just saw a few minutes ago, I explained how a lot of areas cover abstraction, right? Art, music, English, math, as well as math and physics. The computer science degree programs started with calculus, in part, I suspect, I don't know for sure, but I suspect because that's where they were used to, that's where they came from. If the first coders were mathematicians, guess who the first programming teachers were? The university professors. They were from math departments. In fact, I taught with some. I taught with people who were mathematicians, math professors that learned to teach coding. So that's where it came from, right? That's what they knew. So they're like, oh, you teach abstraction through calculus. Let's require calculus. Calculus is not even the part of math that you need, right? Like if you're gonna go deeper on math, which you don't need math to become a six-figure developer, but let's say you wanted to dive deeper, statistics, combinatorics, probability. There are a ton of more logic. There's a ton of more useful topics that you could require besides calculus because it only is relevant to graphics. At least logic is relevant in AI, machine learning, just writing simple if conditions. Like, there's so many more useful areas and branches of math. Most computer science degrees also require discrete mathematics, which is logic, thinking about sets, how they interact and things like that. But the key is that abstraction, the ability to abstract, that is what's important, but not necessarily the calculus. So Amin, thank you so much. Do we use calculus, machine learning, and AI? Actually, we use logic a lot more. It depends on the type of learning you're trying to do. So I want to take a moment and answer this question, but I will get back to Arthur's question. Sorry, I'm looking at the comments because I'm trying this on my phone today. Yes, how much math do we need? Yes, I'm gonna write that down so I don't lose it. How much math? Just in case. I was planning to cover it, but I want to make sure. Okay, so Amin had asked, don't we use calculus in machine learning and AI? This is an excellent question. So strict AI is actually logic-based. A lot of people tend to unify machine learning and AI because it's a buzzword, right? But technically they are different things. Machine learning deals both with some aspects of AI like logic, and literally calculations. Like if you consider calculating, like subtracting, adding, and multiplication, if you consider that calculus, then yes, you need calculus for machine learning and AI. But I don't personally consider that calculus. I consider calculus to be integration and derivatives. And so those are used specifically in complex physical systems where you're trying to model like the speed of acceleration. Like if you're noting a change and it's changing over time, what is that slope of that line? Like those are the types of questions that calculus answers. Machine learning doesn't do that. So there's two areas of machine learning. Some benefit from calculus, but don't require it, right? So machine learning has a lot of logic, decision trees, plans of action. But there's also areas of learning which they're related to machine learning, but technically they're statistical learning methods. So this would be like logistic regression or other linear regression models. Now, you don't actually need calculus to use a regression model because the people that created regression, they understood calculus. Then someone else went and implemented that logic in a library for you. You don't even need it because you just have to call the function that does the linear regression. You don't need to understand calculus to be able to perform the linear regression or the logistic regression or whatever the machine learning technique is. So that's where the disconnect comes. There's a difference between the people that create brand new machine learning techniques and the people that are applying them in new contexts. If you're applying an AI or a machine learning technique to a new set of data, you don't need to understand calculus. You do need to understand like what input to give it so it gives you useful results. That's really valuable, but it's not calculus. It's not calculus. Awesome. These are so amazing questions. Please keep them coming. And then, so Arthur, I don't quite understand. Is that why C is heavily taught in university? It could be. C isn't necessarily tied to math, but it is a historic language. So you can always ask more on that one. If you could dive into that for me, I can answer that one better because I lost the context of when you asked that question. Sorry about that. Awesome, awesome. These are really, really amazing questions. So that gives you a little bit of history, right? And so sometimes in university, we do teach things that are for historical reasons. So yeah, so Amin, just to let you know, I have my PhD. So like I've been through all the courses. This is why I can tell you that you don't actually need a lot of math to be a six-figure developer. I've taken graduate level statistics classes. I've analyzed data. I've published 50 peer-reviewed papers in academic journals about this stuff. Like I know all of those things. I've done machine learning, I've done AI, I've done statistical learning, different things. In fact, my dad has his PhD in statistics. So like, I'm really, really immersed in this stuff, which is why I can tell you these finer grained differences. So you don't have to just believe the hype and believe the myths that are out there, and you can find out what really matters. Like, because calculus is a level of complexity that if you don't need it, it's not a great time investment. Like if you really just want to be a six-figure coder, don't learn calculus. That would be my advice for sure. There's areas of math we might want to learn, right, that might benefit us, but let's make sure that they're really going to benefit us, right? Awesome, awesome. Love it. Okay, so drum roll. Do you need some of this? Do you need some of the math? Okay, what do you need? There is an aspect of math that is valuable, and we already said what it was, abstraction, right? And why do we need it? So the ability to abstract and recognize and define a problem at a higher level, right? Like to recognize that a toy car is a model, an abstract model of a real car. Because for example, I'm not gonna sit down and implement a real car. Like I'm not gonna sit down and implement every bolt and every engine. I'm gonna abstract away based on my problem because that would just be too complex. We can't, when we're as programmers, we cannot implement absolutely everything, right? We cannot implement everything in the world. It's too complicated. We have to abstract and distill it into its essential elements, okay? And so that's the aspect of mathematical thinking that is helpful to us as programmers. For example, what if I want to create a program that uses cars? One way is to sell cars, in which case the abstraction that I care about is the make, model, maybe the VIN number, condition, how old it is, the year. But maybe if I'm making a car for like Grand Theft Auto or a video game, I might not care about those things, or I might care about those things in addition to how does it handle? Because I need to model that in my computer programs. So this ability to abstract our problems is really, really important. So, and the other aspect of math that can be helpful is that mathematical formulas are really, really concise ways of communicating complex things, right? It's a way to simplify what you're talking about. So for example, I'm trying to think of a good example, like the most famous one is E equals MC squared, but I'm not sure that's gonna help necessarily. But it's taking all these complicated things and it's distilling an observation about reality at a super, super high level. So equations can be helpful even when you're coding, but you don't necessarily have to know calculus to understand the equations, because calculus is integration and derivatives. So algebra. Algebra is the level of math that I find most important for programming. So, and algebra, at least in the US, is taught in every school system. So if that's an area where you're uncertain, I actually have a really great book. It's old school, it's out of print, but it's awesome. It's called like Algebra Unplugged. It's the predecessor for Calculus for Cats. It's an amazing series. This guy has a great language, but it really talks about like intuitively what is algebra. And if anybody wants it, I can totally drop the link down below. I make nothing off of this. I just thought it was a great resource for self-learning these concepts. So it is helpful to have that abstract thinking, right? Algebraic thinking, awesome. And so now the question is, do you specifically need to go deeper on this? Is this something that you need to learn, or do you know enough already? So we need to verify, how much learning we have and move forward. So the way we can do that is by writing our own functions. So if you've never coded before, you can kind of unplug a little bit because these words might not make total sense. But if you have been learning to code, my question to you is, hopefully you've been calling the functions that other people wrote, right? The first program most of us write is hello world, and we call print, or some function that's going to display our text to the screen. Okay. But then are you writing your own functions? This is where we see if we understand the abstractions enough to be a six-figure developer, right? In that abstraction of how do we lay out and design our systems? Where do we put the code? And the way we start that thinking process is defining functions with parameters, and ideally it returns something. You can create functions that don't return things, but if you want to practice this abstraction skill, I highly recommend you try implementing a function that takes in parameters and returns something. It could be as simple as adding two numbers and returning their result. That would be a starter function. And then you'd want to kind of move on into more complicated functions. And how do we learn that? Is we learn how to write functions. One way that I usually recommend my students is, if you have a problem, sit down and code it. Forget about functions for a minute. Sit down and code it. And then go back and figure out, okay, what if I wanted to copy and paste that code and do it a second time? What would change? What would stay the same? If something would change, you make that a parameter. And if it's going to stay the same, you let it go. And that's the process you can follow, just super, super bare bones. Like I have a ton more training inside the Joy of Coding Academy on this, but you can kind of work through that process of seeing it. So you can decouple the writing of the code from the from the writing of the function and the abstract thinking skills. Awesome, awesome. I think coding in functional programming language like Haskell or Scheme could help. Yes, that can totally help if that is a place that you want to learn. Functional programming is showing up everywhere. And let me just briefly mention, functional programming is where you use functions rather than usually you don't use loops. Like Haskell is a purely functional language where there's no loops. It's just functions. So all the repetition is what's called recursion. So that does not have to be where you go. You can do it that way. And to be honest, you can also use React and Python in functional ways. So you can do functional programming in an environment that also lets other things be easy. So I don't see a lot of production systems in Haskell, for example. I don't remember about Scheme if it's purely functional or not. It's just been a while since I've interacted with Scheme. It could be, right? Lisp, Prolog, they're all kind of that logic, a different type of programming paradigm. Yeah, recursion is the alternative for loops. Exactly. So if you're telling me like, oh, I don't like recursion, then I wouldn't force yourself into it. To be honest, it took me a long time to get better at recursion. I'm way better now. And actually I had to teach it. I had to teach it. And then I would take a loop and I would rewrite it recursively. And I just kept doing that. And I found a pattern, I found a template that I follow. And so now it's easy, but it didn't start that way. And it took me some work and some investment. And I still had the skills that I needed to be a six-figure developer without that. So that's why I'm just throwing it out there that, you know, how much you push it. You want to be able to solve the problems that inspire you, that are the reason why you're learning to code. Right? So if you're doing data analysis, calling statistics libraries, maybe learning about how those statistics work, but not calculus, might be a better investment of your time. But if you want to really be a functional programmer, then Haskell is an amazing investment of your time. And it's going to make, you know, coding and the latest version of React easier because it's very functional. Do you need all of that to understand it? So I guess the question is, how much understanding do you need? Let me give you an example. So in my university, we have a database course. I've taught it. I don't love it because I don't think we need it. I'll tell you why. Because one of the faculty in my department was actually served as a database consultant. And so he went super deep. He would help advise companies on what their database should be set up like to be efficient. The average programmer that I work with doesn't need that. They just need to be able to get the data up on a website and allow users to interact with it. Totally different skill set. You're just consuming the MySQL. You're just consuming the database. You're not actually like, you know, strategically planning what data needs to be in there. And so I don't think you need a whole course for that. I think it can be like 2 weeks in another course. Whereas this particular person, they went deep. They're an expert on it. And so they see different things. So everybody has different opinions and different experiences based on what they've done as coders. And so that's what I'm actually recommending that you do too, is that you figure out what systems excite you. Because it's way too big out there. There is so much out there to learn. You cannot possibly learn it all. No one can. So the key is being strategic and focusing your attention on what makes sense for you and your career and where you want to go. If you want to go create the latest and greatest rendering engine for Frozen and Disney movies, calculus might be in your future. But if you want to be a six-figure developer working on websites, like that might not be the thing for you. So again, what I'm asking everybody and trying to help support everybody in is finding what software that they are inspired to create, that turns you on. Because software is totally designing our lives, right? Think of how many times you pick up your phone or your computer and you're using software, you're interacting with a website, you're using an app. How does that control your day, right? Software is designing our lives. And I think absolutely everybody in this group can be designing that software. So what software are you going to create? And then that becomes our focus. Awesome, awesome. Thank you all so much for tuning in today. I just love that your questions and your enthusiasm, I love it. Thank you so much. Please keep the questions coming and feel free to post more questions in the group. I check it every day, so you can post in there if you've got questions on where you should go, what career path it looks like for you. Please don't hesitate to reach out, and I will catch you on the other side. Happy coding, guys. Have a great day. Take care.